What it would have been better is if instead, when we do this flipping, that we would have been left with what up here? Think about what, we still want L'Hopital's rule over here, but we don't want the bottom power to ever be bigger than the top, right? What would have been nice to have had up here?
N to the 4.
N to the 4 would have been more than what we need. If that was n cubed right there, wouldn't this have worked? Because then we would have n cubed. When we did L'Hopital, we would have got a constant, wouldn't we have? And it would have been positive? So how could I get an n cubed up here? I would have had to have had down here a what? N squared. Which means when you flip it up, it would have been n squared. These two would have gone together. This would have been n cubed. And then when you did L'Hopital, you would have got a positive constant. So when we were doing our comparison, I have to start over and think through this again. When we were doing our comparison, we had said we wanted to compare it to this. What was it? 2 to the n over n squared. And I said, but I think, and I kind of led you down the wrong path. I said that I think that we can probably use 2 to the n because we didn't really know what that one did, right? But we knew what this one did. Yeah? But I know now I'm going to have to use that one if I want this to work. So I just need to figure out what that one does. Yeah? So let me see if I can figure out what this one does. How about I do the nth term test on this? So what's the limit as n goes to infinity of 2 to the n over n squared? What am I hoping this turns out to do? To go anywhere except 0, right? Anywhere except 0. So it's infinity over infinity. We do L'Hopital one time. Derivative of the top, 2 to the n, ln2. Derivative of the bottom, 2n. Still have infinity over infinity. Do it again. So another L'Hopital, limit, n goes to infinity. All right, natural log of 2 is a constant, so I'm going to ignore it. Derivative of 2 to the n is 2 to the n ln2. But then I still had an ln2. And then on the bottom, derivative of 2n is just 2. Yeah. And that's going to be infinite, right? This is going to infinity, which is definitely not 0. So the nth term test tells us that this series diverges. That series diverges. So this diverges. That's not the answer to the problem now, is it? No, that's just to get my grip on the thing I'm going to compare it to. The thing I'm going to compare it to, I needed to figure out that that diverged. Now I'm going to do my comparison, limit comparison. When I do that ratio and it all works out, L'Hopital's rule is going to go like 2 times or something, and then I'm going to get a positive constant. All right, shall I finish it off? Okay, so I'm going to use limit comparison. I'm doing the limit as n goes to infinity of a sub n, which is this, over b sub n, which is this, which is limit n goes to infinity. And when I flip and cancel, I get n cubed over 4n cubed plus 1. Oh, I only need L'Hopital once, don't I? Y'all okay with the flipping and canceling? So L'Hopital once. We get 3n squared over 12n squared, which is 1/4, which is a positive constant. And I'm happy. I'm not so happy. I'm more like, okay, that's not sad. It's just kind of like indifferent, because I had to work hard for that. So, what's my conclusion? Therefore, this series diverges by the limit comparison test. That was a bit involved, huh? That's why I'm indifferent. Yep. All right. Your only way to get good is to practice, right? So I gave you a homework assignment from this section last time, didn't I?
Yeah.
So what I'd like for you to do, what did I give you last time? 6 through 30? All? But I said the only thing that would be on the test would be 6, 7, and 8, right? Okay. So now, 9 through 30 would be the rest of your homework, and that's going to use, when you do numbers 11 through 30, it's pretty much anything. It can be integral test. It can be, like, they don't tell you. It could be integral test. It could be comparison, direct comparison, or it could be limit comparison. Now, what happened was, and you'll see this if you watch the homework video solutions, when I did the homework for this, for some reason I didn't look at the chapter, like I didn't look at the section. I just started doing the problems. And I forgot that limit comparison was in this section. And I did almost every single problem with just direct comparison. But the last two, I couldn't get with direct comparison. Then I was like, how am I supposed to do that? I can't do that with direct comparison. And so I said, oh, crap, limit comparison is in this section. So at the very end, I do the last two with limit comparison. Then I tell you, hey, if you want to go back and do, and I tell you in the video, some of the problems that I did with the direct comparison can be done with limit comparison easier. So just be aware of that when you do the homework if you watch my video. All right. We good? We're not going to leave yet. Oh, you want to. So that cheat sheet that you're allowed to use with all the different tests on it, right? Which tests are still on there that we haven't talked about? The ratio, the root, the alternating series, and then something, absolute value thing at the bottom, right? Yeah? So what I'd like to talk about, and I'm only going to just this first part of 8.4, we'll do the rest of 8.4 next Thursday. Yeah, next Thursday. What's called the alternating series test. And guess when you use this test? When you have an alternating series. Okay, that's what makes it nice, is that it can be used when you have an alternating series, which we have not had up to this point, right? Everything that we've studied so far, our series has always been positive terms, hasn't it? A sub n is greater than or equal to 0, B sub n is greater than or equal to 0. But what if some of them are negative? Here's the alternating series test. What it says is this. Given a series that looks like this, so what I've been doing so far in the previous sections is we've always been looking at this series, right? A sub n? Yes? And I've said that A sub n is always need to be positive. Well, what if we're looking at a series, again, it's A sub n, it's something, but it's switching signs. If it switches signs, we know that it must contain a negative 1 raised to a power, right? Now that could be plus 1 also, depending on where it starts. It could be positive or negative for that first term, couldn't it? But it must have a negative 1 to make the switching of the signs happen. Yes? Then attached to that is the rest of the sequence, right? This rest of the sequence that we are talking about that does not have the negative attached to it is the B sub n. We're going to call that B sub n from now on, all right? Let me give you an example. I'll get back to finishing the test. If I write 1 minus a half plus a third minus a fourth plus a fifth, well, that's not a fifth. Dot, 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 right? Could you convert that into a sigma notation? You're going to start with the positive, right? How do I start with the positive? Negative 1 to the n plus 1. That would make it start at a positive, wouldn't it? And then the rest of it, what's the numerator always going to be? 1. What's the denominator always going to be? Just n. Do y'all see that? Okay. This piece right here is what we're calling the B sub n. The part that does not have the negative attached to it. Okay? So if you have an alternating series and you focus all your attention on the B sub n, then here's the test. So given us an alternating series, if 1, now I want to follow this here. They kind of do it a little different. I'm going off the book's formula, damn it. You know what I'll do on your sheet? What I'm going to do is have you change it on your sheet, okay? So I'll tell you in a second where to change it. If B sub n is greater than or equal to B sub n plus 1, and 2, the limit as n goes to infinity of B sub n equals 0, then the conclusion is that the series converges. I'm going to give you one example of this, and then, we can start talking test, all right? Maybe 2 if the first one goes fast enough. You ready? Yeah. So to use this test, you identify the alternating series, you figure out that piece that doesn't have the sign change on it, and you just check these 2 things. If these 2 things are true, then it converges. All right? All right. So let's try this example. What if these aren't true? Your test fails. Example. Converge or diverge? I'm going to give you 2 problems in one here. Part A. 1 plus a half plus a third plus a fourth plus a fifth plus dot, dot, dot. Part B. 1 minus a half plus a third minus a fourth plus a fifth, dot, dot, dot. So let's do part A first. What's the sigma notation for part A? Sum n equals 1 to infinity of 1 over n. What does that do? Diverges because it's harmonic, right? Or p series with p being 1. Diverges because it's harmonic. Done, right? We're done. Part B is almost the same series, isn't it? The difference is that it's alternating. So instead of taking one and adding a half and then adding a third and adding a fourth, you take one, you subtract a half, then add a third, then subtract a fourth, then add. So you're like adding, subtracting. And what does this one do? All right? So let's get the sigma notation for this one, for B. And we just did that a second ago when I showed you the example. It was -1, you said to the n plus 1, right? Times 1 over n. Any questions on that? Where this comes from? Okay, what's the b sub n here? This is b sub n. So now I focus all of my attention on the b sub n. I have to show two things are true about that b sub n. So here I go trying to show the first thing. First, I want to show that b sub n is greater than or equal to b sub n plus 1. What this is showing you is that this sequence is decreasing. Isn't that what that means, to decrease? The nth term is bigger than the next one, which is bigger than the next one, which is bigger than the next one. So we're trying to show that this sequence decreases. So take b sub n, which is just 1 over n, and compare it to b sub n plus 1. So we plug n plus 1 into this, 1 over n plus 1. Is that true? Yes, that's true, right? That's true, because n plus 1 is greater than or equal to n, which means 1 is greater than 0, and that is true. So I hope that we've done enough of those that you understand what I did there, just move things around. And so the first of the two things I need to show are true. Questions? What's the second thing? The limit as n goes to infinity of what? B sub n, right? Which for us is 1 over n. That needs to go to 0, right? I want to show the limit as n goes to infinity of b sub n equals 0. So let me check that out. Is it true? Yes? What's my conclusion? Therefore, 1 minus a half plus a third minus a fourth does what? Converges. Converges. So part A of this problem was a harmonic series, wasn't it? That harmonic series diverges. This is an alternating harmonic series. Alternating harmonic series converge. And I think that'll probably be where we can end it, but I'm just going to put one more kind of interesting problem because we still have 20 minutes and it's not going to take me that long to talk about the test. a series that we had talked about a long time ago when we first started talking about series. Just something to think about. 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus dot, dot, dot. What does that do? What type of series is that? It's an alternating series. Can you write it in sigma notation? Well, make it switch signs first. How about negative 1 to the n plus 1? Yeah? And then what would be the thing next to it? What's that? Just 1. Well, it's not getting bigger. They're not getting larger, right? So just 1? You could put n over n. You could also put n squared over n squared. You could pi over pi. You put whatever you want, right? One is infinitely representable, right? You can represent it with an infinite number of ways. That's our b sub n, isn't it? That's our b sub n. So let's see if this will work. Will the alternating series test work? Let's check out the first thing. You want to show first that b sub n is greater than or equal to b sub n plus 1. Well, what's b sub n? What's b sub n plus 1? What is it? 1. Look, our b sub n sequence never changes, doesn't it? You go to the first one, it's 1. This is the switching of the signs, right? But as far as what's happening inside, it's always a 1, isn't it? So this is a constant. Yeah, there's no end. There's no growth in our sequence. So this is always 1, right? If you're looking at the first one, the second one, the third one, the fourth one, they're always 1. So isn't that true? Yeah? Check. So far, so good. Second thing, what's the limit as n goes to infinity of b sub n? Well, that's the limit as n goes to infinity of 1, right? Which is 1, which is not 0. Fails. The alternating series test fails. All right? Now, we are going to have a way of dealing with this next class. But this is a very interesting problem. And let me show you why it's so interesting. I think it's so interesting. See if you can follow this, all right? You ready? So right now, we don't know what this does. All right. What if we call this S, okay? Assuming that it converges, all right? Assuming that this does add up to be something. Let's call it S, all right? If it does. Now, it may not, but just see what, this is just a thinking thing. Then, do you agree that from here down is negative S? So let me rewrite this way. 1 minus, in parentheses, 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus forever. So look, if this is a negative, then a plus, then a negative, then a plus. So if I factor a negative out of everything down here, doesn't it change this negative to a plus, that plus to a minus, that minus to a plus, this plus to a minus? So the ones are the same, right? The ones are the same. Factoring a negative out, I get this. But 1 minus 1 plus 1 minus 1 plus 1 is S, right? Isn't it? So what I'm saying is that S equals 1 minus S. which means that, move the s to the other side, 2s equals 1, which means that s equals 1/2. Boo, why?
Just boo.
In the beginning, that is going to add it.
Well, in this class, we will say this series diverges. All right? We will say that because I made a huge assumption here. I said if this adds up to be a number, then we can call it S. But if this is not a number, I can't call it S. Right? In physics, though, this is the thing that's interesting. In physics, there are problems that come up where they get this alternating series. And everything that they show experimentally works if they replace that series with 1/2. It's an infinite series, but if they replace that infinite series with the number 1/2, everything that happens mathematically matches what happens in the experiment. So you think about a different way of looking at this. Look at the nth partial sum. Okay, see if you can remember this. The nth partial sum. S1 was what I get when I add the first one together. The first one, right? Just the first one? I would get what? 1. Now what if I add the first 2 together? I get 0. Then the first 3 together. 1 minus 1. Now we're back to 1. Now the next one, what do we get? 0. And so if this thing has a sum, if it does, it's the limit as n goes to infinity of this thing, S sub n. But what is S sub n doing? Flipping back and forth between 1, 0, 1, 0, 1, 0. But half is that average, isn't it? It's like the average value of that sequence. So it's kind of this big kind of head scratcher. And there's another one that I'll show you next time. That's another head scratcher that again is used in physics a lot. I believe it's, and this one makes absolutely no sense. I'll show it to you next time. All right, let's talk about the test. Okay, so you're going to have a test on Tuesday. That's all I need. That's all I want to say about it. Hey. I would never do that to you. Look, I typed this up today, okay? So I'm not even pulling old stuff off. You know, I actually did work today.
So you take it out on me? Take it out on your teammate.
Do we have any extras? Okay, thank you. Have an extra? All right. So let's talk about this. Yeah, I'm going to talk about it. So I was thinking about the types of questions that I'd want to ask, going through everything. Find the area between two curves. If you look at section 7.1, numbers 7 and 15, that gives you some idea of the types of curves I'm talking about. All right? Yeah, I mean, I'm not saying exactly that it's going to be a problem just like number 7 and just like 15, but this, when I was going through, what I did is I thought about, okay, what kind of problem do I want to put on test? And then I looked through the homework assignment and I said, hey, you know what, those two, I like those two. They're not too hard, they're not too easy, they're just kind of right for me, all right? So you can go back and look at those. But when you're doing it, these are the things you need to be able to do. You need to be able to sketch the curves, give me a nice, good picture. You need to be able to find the intersections. So remember, you have to actually set the functions equal to each other, the curves or whatever. And then be able to set up the integral, but I'm not going to ask you to evaluate it at all. All right? Then finding the volume of a solid generated by rotating a region bounded by curves about various lines. So if you look at 7.2, numbers 7 and 10, those are good regions. All right, don't look at those problems and say, oh, it's just like that problem. Those are good regions. Now, as far as what you'd be rotating it around, you're going to have like one region. I promised this to you a long time ago. You're going to have one region let's say something like this. There's your region. And then I'm going to ask you most likely to go about at least 2 horizontal lines, at least 2. So maybe the x-axis, maybe y equals -2, and then maybe something y is above it. You're going to have at least 2 rotations with horizontal axes of rotation, and then 2 vertical axes of rotation. So if you're going to look at this region here, if you're going to rotate this around something like this, what method are you going to use? You're going to use washers, right, or discs. And then, but if you're going to have to go around the line this way, you're either going to have to use shells, which is what I would prefer you do, or you're going to have to switch your variables over and solve for x instead of y, and then do washers the other way. And I would avoid that. I'm going to give you a region that you won't have to switch variables on me. All right? So on that problem, be able to sketch the curves, be able to determine the method, be able to set up the integral. Remember, I'll give you one region. You must rotate it about several different lines. All right, next one, find the volume of the solid which has a base formed by the intersection of curves where cross sections are perpendicular to the. You may remember this one, if I draw it, where you had like a region, something like this. And we said, oh, okay, if you take little perpendicular cross sections of this and you cut through the solid, so no rotation here, right? That maybe those form equilateral triangles. So what I did is I drew it out in 3-dimensional space, like that. And then here was your region on the ground that looked something like this. And then your cross sections came in like this, and they formed triangles. And then we just did like, smaller triangles. And you have to come up with a formula for each of these little triangular slices. Once you find your formula, you put it in the integral, you get your volume. So again, setup only. Does that look familiar to you? Cross sections perpendicular to x-axis. So I gave you a couple of problems to look at in the book. Actually, it's just number 43. Length of a curve. Be able to apply the formula. So what's the length of a curve? It's integral a to b, square root, 1 plus derivative squared, right? Yeah. Okay, dx. And so just be able to apply the formula. And you must be able to simplify the integrand. So I said on those length problems, when you do that square root of 1 plus y prime squared, like that part of it usually simplifies. And I want to see you do that algebra. And if you look at number 9 on 7.4, that's the type of algebra I'm talking about. Again, no need to evaluate the integral. Surface area, same thing. Just be able to do some algebra in that, number 7 in that section. And the formula, the only difference between the length formula and arc length formula is 2 pi out front and then y in front of the root, or f of x, however you want to look at it. Determine convergence or divergence of a sequence. 8.1, numbers 5 through 32. That's just me telling you, you should review the homework assignment for that section, because there's all sorts of different sequences that you could run into. All of those problems are just basically the nth term test, because they're not series yet. They're just the sequence. So you're going to be letting n go to infinity on the sequence. L'Hopital's rule might be there. Squeeze theorem might be there. Just look at, there's a bunch of problems. Next topic, be able to find the sum of a geometric series. So can you find the sigma formula from something? So if I give you a bunch of fractions, can you come up with the formula and then identify that it's geometric and then make it look like the proper form of geometric, like a r to the n minus 1? And what really popped into my head was one of those repeating decimal problems. Like something like that. That right there is a nice problem, because it requires that you can first rewrite all these things as fractions, then from the fractions create the formula, from the formula tweak it to make it look just like geometric, and then use the a over 1 minus r to get your result. So those are in, I gave you again problems to look at, numbers 31 through 34 from 8.2, those are like this. Find the sum of a collapsing series. Those are those telescopic ones. So I want you to be able to write the series so that we can see the canceling. And I told you last class, very important that you show on the test that you're looking at the nth partial sum. Show me the canceling that's happening. After the canceling, then take the limit as n goes to infinity. Last thing, determine convergence or divergence of a series. And only looking at nth term test, harmonic series, geometric series, p-series, and integral test. So no comparison on here at all. That's it. I don't even know what this test is going to look like yet. Like when I haven't written it up.
Do you have any idea how many questions are in here?
Let me see. If I had to guess. 1, 2, 3, 4, 5, 6, 7, 8, 9. Probably 9. And some of those might have multiple parts. Like when I'm asking you to determine convergence or divergence of a sequence, 8.1, that might be like parts A, B, C. So you have like 3 different sequences. One of them's real easy. The other one maybe a little L'Hopital. The other one, I don't know, something else.
Are you going to give us options? Pick 7 out of the 9?
No, it's hard to grade that. It's hard to grade that. What I will do is I'll keep everything in line with what I've asked you to do on homework, and I'll keep it in line with what I've done in class. I'm not going to go crazy. This is a lot of information. I understand that. This is part of what I've said about this class. I mean, it's a lot of information that you have to know, and you have an hour and 40 minutes to convey your understanding to me somehow, which is difficult, but. Is that okay? Is that a review? I mean, I hope that helps. I tried to lay out like the things I'm going to be looking for. Other questions? I thought.
There's some things that you did in sequences
Uh-huh.
that you like were required for sequences that you kind of just like changing from n to x for L'Hopital and all that.
Yeah,
Sequences are really
we are at a point right now where going and switching from a sequence with n over to x and then back to n is a waste of time for us now because we understand it. But when I first introduced it, what was my point?
that you had to, that you knew that.
Why do you have to go to, because it's dots, not curved, right? So as long as you know that and that you're actually are doing that and then coming back, we're good to go. But you don't need to for the test. That's okay. You just keep it. Because remember, you can never take the derivative of a factorial, though. All right.